All right, this video is going to kind of be about infinity. We are in chapter 4, section 1. We need to be on page 159. And if you haven't done so already from my previous videos, you need to copy down the core concept in the middle of page 159 because we're going to describe the end behavior. So we're looking at the big picture for polynomial functions. No longer are we only talking about linear functions with positive slopes or negative slopes. No longer are we only talking about quadratic functions, which either open up or open down, happy face or sad face. Now we're going to get a range of functions, and they do boil down to a few basic categories. But the truth is, if you can identify the big picture with these polynomial functions, you can pretty much identify the big picture with any function that comes along your way for the rest of your math career, okay? So core concept, page 159, end behavior of polynomial functions. We're gonna add in some vocabulary, which is gonna go along with example 3. I'm looking down at my book, by the way. Example 3 on page 159. So first, let's actually just go to Desmos and start with number 6 at the bottom of page 159. And then I'm going to add in a few stuff from the teacher's edition as well. Excuse me while I mute my phone. And I'll just keep that in there so that you know that teachers aren't perfect. Okay, so this is page 159, number 6 at the bottom of the page. It says to describe the end behavior of f of x equals 0.25 x cubed. Now, by the way, you should be typing this in with me, or at least pausing it afterwards to practice, because you know I can type stuff in, right? But I'm not the one getting the grade. All right, so here is this beautiful cubic function. It has a degree of 3, which means it is a cubic function. Let's see, its leading coefficient is positive. All right, and well, looking at it, there's a y-intercept of -1. All right, anyway, let's look at the graph. Okay, so first of all, it's a cubic function. The degree is 3. That is an odd power. It is an odd function. Sorry, the degree is odd. It's not actually an odd function. Then we know the leading coefficient is positive. So let's take a look at the end behavior. And again, this is when we zoom out. What is happening as I zoom out and I take a universal look at this? Well, let's see. As my x's get bigger, as x's go towards infinity, f of x, y, goes towards positive infinity. So, or as the book will say, as y goes towards positive infinity, x is going towards positive infinity. As y goes towards, as f of x goes towards negative infinity, right? F of x, y is going down. Where the x is going, they're going towards negative infinity as well. And I like that we can like picture ourselves zooming out of Earth, zooming out of our solar system, zooming out of the galaxy, right? And what is happening? And I'll actually let you describe this cubic function from a very universal viewpoint right here, okay? So describe the end behavior. F of x goes towards positive infinity. Okay, where is it going? Up as x goes towards positive infinity. F of x goes towards negative infinity as x goes towards negative infinity. All right, let me pick a few from the teacher book. So you don't have this, you need to write this down. You need to write the notation down, which you can see right here in the solution of example 3 on page 159. Okay, so here's another problem. You don't have it in your book again, so you just need to write it down and take a look. And you know what? Learn to understand the end behavior, what happens towards the infinities. Where is it trending to? If we let it continue forever, where is it going? All right, so let's start with As f of x goes towards, ooh, we could use a cursor. As f of x goes towards positive infinity, where are your x's going? They're going backwards. X's go towards negative infinity. As f of x goes towards negative infinity, as our cursor goes down, where's our x's going? Where's our cursor also going? It's going to the right, positive infinity. F of x is going towards negative infinity as x goes towards positive infinity. All right, let's zoom out. Do you agree? Where is f of x going? It's going towards positive infinity on the negative side of the x-axis. Where is it going toward? Where is f of x, the function, going towards negative infinity as our x's get bigger towards positive infinity? Okay, I'm actually going to take this moment to pause my video for a second and write it out for you. Let's see if I can actually pause the recording. All right. Honestly, I hope that pause worked. I wrote out the function. I'm still looking at my Desmos, but now I'm going to share with you my notebook so that you can at least feel confident writing down the description. Notice I put letter alpha. Remember, if it's in Greek, you're not seeing it in your textbook, and you better not have the teacher's edition. Okay, so we talked, let's actually just sketch a quick graph here. All right, so it looks something like this, right? So as f of x go towards positive infinity, the x's, okay, so f of x, as the function goes towards positive infinity, our x's are going towards negative infinity. When our function's going towards negative infinity, our x's, and by the way, it shouldn't be a comma, it should be the word as. Our function goes towards negative infinity as the x's go towards positive infinity. Okay, positive, oh, look, make that a little bit better. Positive infinity, okay? All right, let's do one more, and you're gonna have a lot of practice. You will need a lot of practice. On your own and with some classmates, because it's a language we're talking about here. All right, so let's write this down first in our notebook. Again, you don't have it in your book. This is beta f of x equals negative x to the fourth. I know I don't have the best handwriting. Minus x cubed plus 2x squared minus x minus 3. Let us turn to Desmos. Of course, it takes a little bit on my computer. All right, so this is a little different, I hope. Same idea though. Negative x to the fourth minus x cubed plus 2x squared minus x minus 3. Okay, so what is happening? Well, wait a second. It's facing down. Both of them are facing down. Both sides of the x-axis, towards the positive, towards the negative infinities, it's both going down. So f of x is going towards negative infinity as the x's go towards positive infinity. F of x is going towards negative infinity as the x's go towards negative infinity. All right. Do we see that there's no f of x going towards positive infinity? The maximum is right there. Oh, and look at our little x-intercepts and our y-intercepts. Okay, so I'm going to stop that. Let's turn to the notebook. Let's make sure we write it down correctly. So, oh, let's draw a sketch real quick, just to remember. You should be looking at it on your screen, but then again, maybe you don't have enough screen space. Like I don't have enough screen space. Okay, so general sketch, right? Goes down both sides. So let's start with the right side, okay? Like let's start over here. So f of x is going towards negative infinity as our x's go to the right as x goes towards positive infinity. Now let's go over here. F of x is still going towards negative infinity, right? It's going down as x goes towards negative infinity. Okay, and then there you are describing the end behavior. Oh, by the way, even function, even degree, leading coefficients negative. There is a pattern. And you know what? Just to put a little thought into your noggin, I wonder what all this does. Okay. All right. Just like the previous section, just like the previous videos, right? There's going to be a lot of practice. The more you practice perfectly, as perfect as possible, practice being or doing these perfectly, the more it will make sense, the more it will become natural. Okay.